As we get ready to jump into the world of computer programming, we want to make sure you have some sense of what exactly are we doing? How does this work? I always think that computer programming is almost like magic. And so, how do we get from this idea in our head to something that the computer can actually do? And the process that we're talking about is coding and compiling, and it can get really technical. And our purpose here is not to get into those technical details, but to approach it as beginners and say, well, just in a really broad level, in a really general sense, what does it mean to write a program and how does the computer run that program? In an effort to keep things simple, I really am going to gloss over a lot of details that if you are a knowledgeable computer programmer, you may kind of wince every once in a while and say, ooh, that's not quite right. It's not my intent to be inaccurate. I don't want to say anything that's wrong, but I am trying to keep it at a really simple level. And so by necessity, I'm going to skip a lot of details. We are sitting as we speak or as we listen at a computer. This device that I mentioned, magic. You talk about magic. Well, how on earth does a computer work? We have this sense that it's a bunch of ones and zeros and all that kind of stuff. And a computer, a processor, understands a language, and we call that a machine language. It's really low level. It's developed and implemented by people who are a lot smarter than me. Computer science engineers that come up with this stuff. Meanwhile, we are humans, and very few of us speak machine language. We speak a human language. For example, right now I'm using English, and there are many human languages out there, obviously, and it turns out there are multiple machine languages out there as well. Now, a human can know a machine language, otherwise how would it have been invented? But it's a really specialized knowledge, right? Whereas a human language, pretty much all of us know at least one human language, and some of you probably know two or three human languages, and I'm jealous of that. But it turns out that humans and machines have a difficult time communicating with each other, at least at times we do. And we've come a long way, for example, in how well machines can understand the things we're saying. But if you've spent any time talking to Alexa or Siri, you know that sometimes it doesn't get it right. It turns out that's a really challenging problem to solve. There's a big gap between machine language and human language. That's where the idea of a programming language comes in. A programming language sits in the middle of that gap, and it's kind of a bridge. It's something that is easier for a human to learn than machine language, but it's also something that a computer can convert into machine language so that it can run it on a really basic level. You've almost certainly heard of some computer programming languages. Java and Python are pretty well known, JavaScript, C++. There are literally dozens and dozens of them. They develop for a variety of different reasons. Some of it's just historical as things evolve. Often it's purpose driven, that somebody has a problem they're trying to solve, and sometimes creating a new language is a good way to solve that, or to make a set of tools that will help them solve that. But there are a lot of them out there. We can think of them as sitting in this gap between what I want the computer to do and the computer being able to understand how to do that. If you have seen computer code before, it's something that you may not understand a lot of the details of it. Certainly if you look at code and you're unfamiliar with it, there's a lot that will be confusing, but there's also stuff there that you can make sense of. That's the whole point, and you can learn the things that you don't know about a computer programming language. And when you sit down at a text editor and you type that in using your whatever computer programming language you're working with, we call the result of that source code, and that's where we get this term coding and things like that. So the workflow is that we're going to type our source code into a file and we're going to save that. And if we have this idea that we're really trying to take what we want the computer to do and explain that in a different language, there has to be some kind of translation that takes place, right? And so we need one more piece of the puzzle here, and we call that a compiler. And here's where I start to lose some accuracy or some technical detail as I try and keep things a little simple. But we're going to say for now that this next step involves something generically known as a compiler. And you've installed a compiler on your computer in order to get started with this whole process. If you're working with Java, you've installed the JDK. If you're in Python, you've installed Python 3 or something like that. Those packages have other things involved in them, but the most important part of those packages for our purposes right now is that they include a compiler or something that does a similar job to what a compiler does. At its core, the job of a compiler is to take in some source code and spit out machine language. Again, we're greatly simplifying that. But the workflow we end up with overall is the human's going to type up some source code. They're going to hand that source code to a compiler. The compiler is going to convert that into something that the computer can actually run. And as you get into programming, you hopefully will start to learn a little more about these things that I've kind of brushed over and made really general. But this hopefully gives you at least a little bit of context so that now you can jump in and start trying some programming.